Okay, so in this section, we'll be looking at number patterns and sequences. We'll be looking at three types of sequences: arithmetic sequences, quadratic sequences, and geometric sequences. And in this specific video, we'll be focusing on arithmetic sequences. So let's get started. Okay, so first of all, what is an arithmetic sequence? Well, if you would like the fancy definition of what an arithmetic sequence is, it basically says that an arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. Now, personally, I'm not a fan of fancy definitions because they sometimes tend to confuse people. For me, if you just understand what an arithmetic sequence is and you can identify one, I think that's more than enough. So I'd actually like to demonstrate the idea of an arithmetic sequence through an example. And this is actually something you should have seen in grade 10 already. So let's look at an example. Say we have a sequence as follows: 2, 7, 12, 17, and it goes on. Okay. Now, I want you to think, starting from the first term, okay, which has a value of 2. If you jump from the first term to the second term, how much are you adding, or what is the difference between these two terms? Well, going from 2 to 7, we are simply adding 5, right? And then if you're going from the second term to the third term, in other words, from 7 to 12, how much are we adding there? Well, we're adding 5 again. And you'll see that it's the same for going from the third term to the fourth term. You're adding 5 again. And so you can see that there's a pattern that's forming here. So this over here, this is what we would call our first differences. Okay. So this is characteristic of an arithmetic sequence, is a constant first difference. In other words, going from 2 to 7, we're adding 5. Going from 7 to 12, we're adding 5. Going from 12 to 17, we're adding 5. In other words, we have a constant first difference. Okay. In this case, 5. And that is basically what an arithmetic sequence is, where the difference between the consecutive terms is constant. Okay, so now that we know what an arithmetic sequence is, and we know what it looks like, and we know how to identify it, we want to be able to go and determine a general formula or general solution for any arithmetic sequence. And a general formula is kind of like an identity of an arithmetic sequence. So it'll tell you, for example, what is the value in the sequence at a specific term, for example. So this is a very nice formula to use. You'll be doing this again in grade 12. So I think maybe we should just look at the previous example we did and then apply this formula to that sequence and see how we can find a general formula. So in the previous example, we had the following. We had a sequence of 2, 7, 12, and 17, right? And it went on. And we saw that we had a constant first difference, right? Which is characteristic of an arithmetic sequence. We had a constant first difference of 5. Okay. So now let's just discuss this formula a bit. Okay. So first of all, n represents the term number, right? In other words, term 1, 2, 3, 4, etc. So now, Tn over here, say for example we were considering term number 3. Then you'd say T3. So in the place of n we would have 3 because we're considering the third term. And T of 3 would then represent the value at term number 3, which would be 12. So T3 would then be 12. Okay. A represents the value of the first term, in this case 2, and D is our constant difference, okay, in this case 5. So D you could think of as difference, okay, and A is the first letter in the alphabet, which represents the first term's value. Okay, so now let us use this formula and try and find a general equation or general solution for this specific sequence, arithmetic sequence. So we would start by writing out Tn. Okay. Remember that we want to find a general formula for this specific sequence. So we're not going to fill in any values for n because we want to be able to find a formula in which we can just substitute any term, like term 3, and then the equation should spit out a value at that specific term. So Tn is equal to, okay, so the first thing we need is a, which is the value of the first term. So in this case, it's going to be 2. Then plus d. So d is our constant first difference, right? Which is 5. Awesome. And then just n minus 1. Okay. And then you can go and just simplify this. So you'll have 2 plus 5n minus 5. And then this will just simplify to 5n minus 3. And this is then our general formula for this specific arithmetic sequence. Okay, so now that we have a general formula for this specific arithmetic sequence, what can we do with it? How does it help us? Well, say for example, I wanted to determine what is the value at term 199 in this sequence. That's a little insane, right? I mean, what the first differences are. There are constant. It's 5. You can go and you can write out all 199 terms if you wanted to. But I mean, it takes time. And this formula really helps save time. So what we would literally just do is say, so we want to find the value at term 199. So we literally just have to sub in 199 into n's place because that is the number of the term. So we'd say equals 5 times 199 minus 3. And then that will give us a value of 992. So that's quite a large value, and it's not something you'd be able to work out easily without this formula. Another question you might want to ask yourself, for example, is at what specific term will I find a value of, say, 497? So now you're looking for the value of n, okay? So the value at that specific term is going to be 497, right? Equals 5n minus 3. And now you can just solve for n to figure out at what term we will have the value of 497. And so you take the 3 over, giving you a value of 500 equals 5n, and then you'll see that n is equal to 100. In other words, at term number 100, we will find that there is a value of 497. And so you can see a lot of useful things we can do just by finding this general formula, things that we aren't really able to do very easily without this formula. I mean, when you in a test, you don't have time to go and write out the entire sequence. It's going to be a headache. So these general formulas really help a lot.